Okay, new chapter, but really nothing too new, except we're doing two means. So I want you to understand, because you're about to do a project and you're going to pick your own question. And I want you to see where you would do something for one mean z-test or one mean t-test as opposed to a two mean z-test or t-test. So I gave you two questions here. Do females at MCA spend 10 hours or less on Instagram per week? So then what would I do? I'd collect my data from random sample of females at MCA. Okay, that would be a one mean t-test actually, but we're going to say z-test. Let's say I knew the population, okay? Population standard deviation. The difference would be if I change that into the following sentence. Who spends less time on Instagram per week, males or females? And I did now two different means, and I compared the means. And I saw, oh, the boys are spending an average of about 8 hours, whereas the girls are spending an average of about 9 or something like that. That's the difference. So if you have questions like this, where you're comparing males to females, you are going to be doing a two mean test, okay? And you probably won't be doing a z-test, even though that's what we're going to talk about today. We're probably going to be doing a t-test because you might not know the population standard deviation. But I just want you to clear this up based on what your question is, okay? I did personally, when I did my project, I compared my classes. I compared the means, the averages on a quiz that I gave when one class listened to music and another class didn't listen to music. And you could do something like that, okay? But this is what we're going to talk about today. Z-test for two means. All right, so we obviously, I've been saying it, when do we know to do this? When we're comparing two means and the population standard deviations, they're known. You have to know them, okay? You know that. You knew that. All right, and some general assumptions. Both of the samples are random. So again, if I'm doing a project with males and females, I'm going to randomly choose males. I'm going to randomly choose females. Both the samples are independent from each other. Again, meaning that I wouldn't want to choose a female who's decided to also be a male kind of thing. You're trying to do that they're completely independent from each other. One group doesn't have anything common with the other group. And that the standard deviations of both the populations is known, okay? You have to know them both, and they're approximately normal. Then you use the z-test. And again, this is going to be very familiar to you, this hypothesis test. We're going to change it up in this chapter, and we're similar things. We're still, number one, going to state our null hypothesis and alternate hypothesis. We're still going to state the significance level. Alpha is, 0.05. Alpha is 0.01. And they should always give it to you. Now, in your project, you are picking your own your significance level. Then step number 3, there is a way to get the test statistic for these, but I would much rather you just look at the p-value. So you're going to, step number 3, write the p-value from your calculator. Step number 4, reject or do not reject. And then step number 5, summarize. There is enough evidence to say that males and females, have a difference, or there is not enough evidence to say that males have a different amount of average time spent on Instagram than females or males. All right, so you should have downloaded this. We're going to do these two questions together, and that's going to be it for today. So, number 1, a study using 2 random samples of 35 people each found that the average amount of time those in the age group of 25 to 35 years spent per week on leisure activities was 39.6 hours, and those in the age group of 46 to 55 years spent 35.4 hours. So again, our two groups are 26 to 35-year-olds and 46 to 55-year-olds. So I've got a mean sample for group 1. I'll call it X bar 1. That mean sample was 39.6. My mean sample for the ages of 46 to 55, we'll call it X bar 2, was 35.4. Assume the population standard deviation for those in the first group found by previous studies is 6.3 hours. So my standard deviation population for that first group age is 6.3. It's known. The population standard deviation of those in the second group found by previous studies was 5.8. So that's 5.8. And then what's the other thing we need to know? Well, we need to know how many people were in each group, and that was right here at the beginning. There were 35 in each group, so we'll call it N1, 35, N2, 35. At the significance level of 0.05, can it be concluded that there is a significant difference in the average times each group spends on leisure activities? Okay, so step number 1. State your HO and your HA. So this is going to be a little different. My null hypothesis would be that their average means, their mu's, would actually be equal. They don't equal something. They're both equal to each other. There's really no difference. But my hypothesis is saying, no, there is a difference. I'm thinking they are not equal. I'm the researcher. Okay, so that's my claim right here. So step number 2, state your significance level. My significance level is alpha is at the 0.05. All right, step number 3, we're going to find it in our calculator. And what you have to do in your calculator, and I'll write this down, move this over, you go to Stat, Tests, and we are going to go, you can see it right there, to sample Z tests, because we have 2 samples and we're doing a Z test on them. And now we are going to input some statistics. So the population for 1 is 6.3. The population for number 2 is 5.8. Whoops. Our sample mean for 1 is 39.6. Our N1 is 35. That's why I was labeling it like this, guys, so you can easily look. Our sample for the second group, 35.4. And our N2 was 35 again. So we're looking again to see if there's a difference. Not that the males is higher, not that not males, not that the ages of 26-year-olds are higher than the 46-year-olds, that they're different. So this one, go down and hit calculate, and there's Mr. P. P is 0.0037, so 0.004, which is, and we know this, but I'll like to highlight it. How do these two compare? Is 0.004 less than 0.05? You betcha. Okay, so what does that mean for step number 4? That means if your P is low, we still reject the HO. And then I want you to obviously summarize this. If you reject the HO, then there is enough evidence to support the claim that the means are different in average times spent on leisure. And that would probably make sense, right? Did I spell leisure right? Yeah. All right, let's try one more. And it's just this easy. If you understood last chapter, you'll get this one. So this would probably be more like what we're going to be doing as a researcher. A researcher hypothesizes that the average number of sports that college offers for males is greater than the average number of sports for females. Interesting. They think it's that males are getting more college offers. Random sample of the number of sports offered by colleges for males and females is shown. At a 0.10 significance, is there enough evidence to support this claim? Assume that the populations are equal. Okay, so obviously you're going to have to input this into a list and list 2. And I know you didn't. I did. Don't worry. Okay. But before I put it into list 1 and list 2, I do want to kind of write stuff down. So go to, just to look, whoops, stat edit, just to see. I already inputted into my L1 and my L2. And then I'm just going to go to StatCalc 2 vars. 1 vars is what we always go to determine a 1 list mean, but you can go to 2 vars and it'll do 2 lists at the same time. See list 1, list 2, and then calculate. And let's see, my X bar, that's for my L1, is 8.56. So I'm going to call that X bar 1, 8.56. My standard deviation for both of them, they said, was 3.3. So even though it's about 3.3 for the sample and for the standard deviation. So that'll be good. And my N, there was 50 males. All right, for the females, my X bar, in the calculator, when you do a 2 var stat, it actually calls it Y bar. So 7.94. And again, their standard deviation is also 3.3, and there was 50 of them. Okay. Now, number 1, state your hypotheses. I think that they would be equal according to the population, but the claim that I'm giving, according to the researcher, is that males is greater, so that the mu1 is greater than the mu2. The significance level, alpha is 0.10. Number 3, let's find our p-value. Our p-value, we got to go to stat, tests, oops, if you can see it, sorry, 2 sample z-test. You're going to do data, and you're going to have to input the population standard deviation, which in this case is 3.3 for both of them. And then my list 1 is for the males, my list 2 is for the females. Leave the frequency alone. And then obviously change this, that mu1 is greater than mu2. Let's hit calculate. And look at that p, 0.17. Is that less than or greater than? That is comparing to the significance level. That is greater than. Well, that means it's not low. So we do not reject the HO. Which means, well, is there enough evidence to say that males get more college offers? No, there is not enough evidence to support the claim. That colleges offer males greater than females. Sports scholarships, I should say, but all right, you can get it. All right, so try your homework, take a picture and send it to me. Bye.